3.2. So we're going to take a look at weighted and trimmed means and outliers. So you should know what outliers are. I think we've talked about that. But weighted means or weighted averages and trimmed means or trimmed averages, that might be brand new to you. So let's take a look here. Let's read along here. In some of the questions in the previous section, the calculated mean, the median, and the mode were quite different. These calculations could be skewed or distorted. I'm not sure if you've heard these words before. Probably distorted you've heard, especially if you're a guitar player. But if we're talking about skewed, that means that they aren't accurate for some reason. There's something that's throwing the average off or the data off. Okay? So we have to examine sort of why that might be, because the measures of central tendency should be pretty close to one another, unless we have some data that are really out of whack, okay? Something that's really odd. So if there's a number that is quite different from the other numbers in the list, this number is an outlier, as discussed in Chapter 1. An outlier is a data point that is significantly different from the general trend in the data set. An outlier can have a considerable effect on the arithmetic mean. So think about this. If there's, if we have a class and we have test marks and everybody's in the 80s except for one person got in the 30s for some reason, then the average would be, jumped down. It would be bumped down quite a bit because of that one test. And maybe the one test is not a real good representation of the entire class, right? You can agree with that? All right. So to account for this, a trimmed mean may be a more representative measure of central tendency. So what is a trimmed mean? Well, if we look over here, and this is in your workbook there, in your notes, you should have that in front of you. The mean calculated by what? Disregarding an equal number of data points from both ends of the range. Okay, that's what a trimmed mean is. An equal number of data points that are removed. So let's say, in this example, look at this example. We have a list of numbers here, 3, 9, 5, 8, 4, 6, and 20. So which one of these do you think would be the outlier? Or be the one that is vastly different from the rest? Probably not hard to see, it's 20, right? Everyone else is single digits except for 20. So we have an outlier, okay. If we don't do anything with those numbers and we calculate the mean, add them all up, and divide by 7, that's the number of numbers we have, we get a mean of 7.9. Okay, you think, 7.9 is not that bad. But what happens if we were to consider this 20 or eliminate the 20? Well, remember, if it's a trimmed mean, to be truthful here or to do it right, we have to take an equal number of numbers from either end of the range. So if we want to eliminate this 20, we would have to take the 3 away as well. So if we eliminate those two, and then we calculate the mean with what's left, that's called the trimmed mean. All right? So the trimmed mean doesn't have the 3 over here, and it doesn't have the 20 over here. So we add up the rest of the numbers divided by now 5, and we get a trimmed mean of 6.4. So what was the other one? The other one was 7.9. So that's quite a significant difference. Okay? 6.4 looks like a better representation probably of these numbers anyways, right? 7.9, I mean, that's pretty high actually. So that gives us a better picture. Okay? Now I won't do the alternate solution to confuse you, but you can read this a little bit later if you want. It's just a different way of accounting for it. So let's do some questions together. Yeah, question?
Why would you eliminate the lowest?
Okay, why would you eliminate the lowest one as well? That's a good question. If you have one number that's an outlier, I see what you're saying. You can eliminate that one number, and that might be okay, but it's kind of like think about an equation. If you take something off the one side, you really should take something off the other side. Or if it's a scale, you take something from one side, you should take something from the other side as well to kind of try to balance it out a little bit. So the trimmed mean is trimming the same number of numbers off of either end to try and get down to what's like the body of it, the main, not the extreme kind of outliers, but so if you take one from the top, you should take one from the bottom as well, just to kind of counteract that a little bit. That's a good question. Okay, so the data set contains the following numbers. Here's the numbers. They don't look like they're in order, okay, from least to greatest. Calculate the arithmetic mean. All right, let's take a moment to do that. You've all got a calculator in front of you. So let's calculate the arithmetic mean. We're going to add all these up, aren't we? And then we're going to divide by the number of numbers that we added. So take a moment to do that. All right, so if you add up all the numbers, you should get 2,185, and then you divide that by the number of numbers, which is 10. So you get an arithmetic mean of 218.5. Okay. Now, the second part says identify any outliers that may exist and calculate the trimmed mean. Now, we could take more than one off each end, actually. You don't want to take too many, but let's just see what the outliers might be. And what you might want to do is you might want to reorganize these numbers from least to greatest. So you could do your stem and leaf chart and do it that way, or you could kind of just, this is 10 numbers, so it's a lot of numbers, but you could probably glance. So let's just do this on our own here. Let's do let's write the smallest number at the top and the largest number on the bottom. Let's see if we can do that. What's the smallest number that we see here? Is 125 the smallest number? Okay, what's the next one? 129, is that right? So 129. Next would be 132, and then 133. All right, and then 154. And then 164 looks like. And then 165. Then 183. And look at these last two numbers. Ooh, 476 and 524. Wow. So I'm looking at this, and I'm looking at these two numbers right here. Anyone else noticing these two numbers? Like 300 more than the last one, right? And almost 350. Anyway, so these ones look to be really different from the rest. Can everyone see that? Would you say? Now the 476, you might think, oh, let's leave the 476 in there. Well, look at all these are 100s, and then we've got a 400, 500. So if we do a trim mean, I would say that these two would both be outliers. They would not be like the bulk or the majority of the rest of them. Yeah?
Since we're taking two outliers out,
Yep.
that means we have to fit two more.
Very good. Yeah, so your question was, since we're thinking about taking these two out, I was going to get to that, we have to take also two from the other end. And now we've got them written in order, we know exactly which ones we need to take out from this end. So we're going to eliminate those four numbers. And we're going to focus on this. Now, again, you don't want to take too many numbers out. You really don't. But if you have significant outliers, you need to, we need to focus on getting rid of those. So now we add up these numbers. Okay, so let's do that. Well, I'll do that here, and I'll spare you that. So you add those numbers up, and you get 931, and you divide by 1, 2, 3, 4, 5, 6. So now we divide by 6. So let's see. What do we get? 155 point, let's say 2. 155.2. 55.2. Now, if we take a look at all of these numbers again, even the original ones, all right, and we look at this 155, is that a better representative of this data really than 218? Since we have 8 numbers that are in the 100s, and we only have 2 numbers that are not, an average that's 155 looks to be a lot more appropriate, I would say, than the 218. What do you think? Right? So that's called a trimmed mean, all right? And there's going to be some other questions they're going to ask you to do that. With temperatures here, I guess if you have to do the trimmed mean for temperatures, you would take, if there's one temperature that's pretty high, then you would take that one off and look at this. These are all negative temperatures except for this one, right? So that one is quite a bit different. You have to take this one, and then you have to take the lowest number. So the highest number here is 15. The lowest number is negative 14. Okay, so that's coming up in question number 2. Okay. But what we'll do is I will move on to the second part of this lesson is the weighted mean. Okay, the weighted mean. So we'll just put those build your skills questions aside for now, and we'll look at this example and talk about the weighted mean. All right. So this is page 125 in your workbook. And it says this: in a weighted mean, the data points are not all of equal value. They're not all of equal value. For example, a teacher might assign different weights to different parts of a student's grade. Assignments might be worth 45% of the final grade, a quiz worth 15, and an exam worth the remaining 40. In this case, each data point is worth a percentage of the total. So this happens a lot in schools and grading schemes, right? Tests are worth a little bit more than daily homework, right? Or whatever it may be. And so we can find, and your grade would be a weighted average of all of those different categories. A weighted average. So if you get 100%, on a 5-question quiz, that's not going to be worth as much as your 85% on a major exam, right? So 100% versus 85%, if we were going to consider your final grade, the exam would be worth a lot more, probably, right? So that's called a weighted average. All right? So here's the example. Frida earned grades of 85, 72, 65, and 90 on 4 tests in 1 term in her math class. If each test were worth the same percentage of her final grade, what would be her final grade? Well, if they're each worth the same, then you just find an average just like regular average. Okay? If each of them are weighted the same. An 85 and a 65 have the same importance, okay? Because they're both of the same type. They're both exams. So 2 ways you could do it. You could simply just find a regular arithmetic mean. Add them up. There's 4 of them. Divided by 4. You're done. Okay? So what was her term mark, though, if the first test was worth 10% of her final grade, the second and third were each worth 20, and the fourth was worth 50? Okay. So this is a very different setup. I'm going to skip to the solution to this, and then we'll do an example from scratch. So in A, you see it's just a regular mean. Now this is what I want to focus on for this part. Okay. Now there's some notation here that's a little funny as well, so don't get freaked out by this. But do you remember what x bar equals? Remember we talked about that? X bar? It was a long time ago, maybe. It might even have been in Workplace 20. I'm not sure. This is the symbol for average or for mean. X with a little bar on top. Okay, that's the average. Now the mean is going to come this way. Now watch carefully. So 85 is the first test. Is that back there?
Yeah.
Okay. All right. If you know whose that is, you could maybe put that on silent. Would be good, please. Back at the back. Thank you. All right. So 85 is worth 10%. So look at what they do. They take this raw grade, 85, and they multiply it by the decimal form of its weight. Look at this. It's 10% of the grade. So take 85 and multiply that by 0.1. Okay? Then the next 2 tests were 20%. So 72 was her next exam, and then you multiply that by the decimal form of its weight. 65 was also worth 20%. Multiply that number by the decimal form of its weighting. And then 90 is worth 50%. This last grade. So take the raw grade and you multiply it by 0.5. This is how you weight each value. Okay, that's how you weight it. And then when you're done weighting that, you simply add up all of the numbers that come from that. Okay, you add them all up. So these are the numbers that you add up, and the weighted average or the weighted mean is 81%. So if all the tests were equal the same, the average would be 78%. But notice this here. I'll go back to these marks. Do you notice how, I don't know if this was a he or she, I can't remember, but this person did really well on the test that was worth the most. You see that? So that mark was a really good mark on a test that was weighted heavier than the others. And so that test yielded the largest portion of her final grade. You see that? Look at all those marks she got. Okay? All right? Any questions about that? Because we're going to get lots of practice. That looks kind of weird right now, I know.
I have a question.
Yeah, question. So the good question was, once you get these numbers, what do you do when you add them up? What do you divide by? And because we've multiplied by a fraction, okay, we don't have to divide by anything now. because these are the actual numbers that we just add up. So this business up here, by multiplying by the decimal form of their weighting, that takes care of dividing it by a number of tests or whatever. You see, this one here, the reason why we add up all the numbers and then divide each by 4, check this out, and this may help you understand, okay? This is really important. This right here is exactly the same as going like this. 85 times 1/4 plus 72 times 1/4 plus 65 times 1/4 plus 90 times 1/4. Now, these are all the same, right? Look at that divided by 4. If I were to change 1/4, what would be the decimal for 1/4? What's the decimal for 1/4? What is it? 0.25. So look at this. 4 tests that are equally weighted, each would be worth 25%. You see that? So really, this is like saying all of these tests are equally weighted. And each of them have a quarter of the total weighting, because there's 4 of them, a quarter. If there were 10 of them, and they were all equal the same weight, then you would add up the 10 marks, divide by 10, because each of them are exactly a tenth of the final. You see what I'm saying? So really, we're doing weighted mean even with simple arithmetic mean. We're just dividing each by the number of, so that means that each of them have an equal piece or equal slice of the pie. Okay? Over here, all right, this 85%, if we're talking about slices of the pie, is only 10% of the mark. 10. The 72 is 20. That's the 72, you see? So it's got a bigger slice of the pie. The 65 is also 20. 65, let's say that they're both 20 there. Not exactly. And then the 90 is 50% of the pie. So they're not all evenly weighted, you see? They're weighted differently. And so this 90 is going to be a bigger chunk. Good question, though. Okay, I hope that clears things up. Let's do one more build the skills here. Okay. So Karina is calculating her final grade in her Spanish class. In the course, assignments are worth 15% altogether. Each quiz is worth 5%. The presentation, 25%, and the final exam, 45%. So you guys are pretty lucky because you get to look online there and you see your grades and everything is calculated already for you. It's the teachers that have to plug in these weightings, right? Everything is already calculated for you. But if you had to do it by hand, this is how you would do it. And of course, in math class, I try and teach you the principles behind the things that are automatically done for you. That's what education is about, right? Let's learn how this is done. Let's actually do it by hand so that you kind of understand what the computer's doing, what the calculator's doing, what the machine is doing, you know, what the math is behind this and this and this. So we have to learn how to do these things by hand in order to help us understand them a bit better. Okay, so Karina's calculating her final grade. Okay, so the assignments are 15% altogether. So where are her assignments here? 8 out of 10, 6.5 out of 10, 16 out of 20. Okay, those are the assignments. And these are worth what in the mark? What percentage? 15. Okay, 15. All right, okay. What about, each quiz is worth 5%. Okay, so this quiz is 5%. This quiz is 5. This quiz is 5. Okay. Presentation. Oh, there's one presentation. That's 25%. Okay. And 86 is her final exam, and that is what? 45%. All right? So now what we got to do is put this all together to find out her total grade. All right, it might be easiest to start with the categories that only have 1 mark. Okay? So whatever she gets in this category, the final exam category, that's 45% of her mark. So it doesn't matter where you start. I'm going to start with that one. So here's the solution, okay? And you guys can just simply write this down with me as we go. This is part of your homework. So we're going to do 86 is going to be her percent for that category, and we're going to multiply by the decimal form of the category weight. Okay? So that's the first, that's this one taken care of. Everybody see that? Yeah? We're going to add to that the marks that she's going to get from this one right here, the presentation. Okay, so what is 85 out of 100 as a percent? That's easy, right? So that's 85%. Right? And you can write the percent if you want there. 85%. And that's going to be times that category is worth 25%. All right? Okay, cool. Now, each quiz is worth 5%. Each quiz. Okay, so that's this quiz. She got 10 out of 10. So what is 10 out of 10 as a percent? That's 100%. So she got 100% times, what's the decimal form of 5%? Is it 0.5? Thank you, 0.05. Very good. Okay, so that's this one. That one's taken care of. The 7 out of 10. Okay, well, that one is 70%, right? Times, again, that's 5%. That one's taken care of. And then another 70%, and I'll just come over here. 70% times 0.05 as well. Okay. Now, here's where it gets a little tricky, I guess. This whole category of assignments is worth 15%. Okay. So, do you think it would be appropriate for us to multiply this mark by 15% and this mark by 15% and this mark by 15%? Like, is that different than this one? I guess that's what I'm wondering.
Well, there is the
Say again, sorry?
Like the 16 on 20 seems like differently, but I think it would just stay the same just because you're doing it.
Okay. So the 16 out of 20 seems like it's a bigger deal in this whole thing. Is that right?
Yeah.
Okay. So assignments are worth 15% altogether. That wording looks like it's a category grade like this. So, okay, so do we need to consider that this is a bigger assignment? And if we do that, what do we multiply each one by? Would we multiply each one by 15%? Or would we multiply each one by, what, 5%? I don't know. What do you think? Okay, so we had some discussion about how we're going to deal with this assignment section. What did you guys come up with? All together? So you want to find out kind of the average percent on all of these together and then multiply it by 15%? Would that be this? Is it frozen? Sorry. Would it be the same as multiplying each of these assignments by 15? Let's actually figure that out first, okay? Because I want to know that. I want to know. So let's say that this is 15%. What if we did each one of these by 15? I just want to see. So this is an aside. So that's 80% on the first one times 0.15, right? And that's 65% on the next one times 0.15. Okay. What's 16 out of 20? That is 80% times 0.15. Okay. So if we took each one and we multiplied that, what do we get? You guys help me out. Do the first one, do the second one, do the third one. Over here. Okay, what do we get? What's 80 times 0.15? It is 12. Okay. What's this one? 9.75. Okay. What about this one? Oh yeah, same as the first one. 12. Okay, so what's that? 2433.75? That's what you get when you add those all together. Okay. So what was your suggestion? You were thinking of finding out what the average of all three of these are equally? Okay. So, like, were you adding up, so this is like 10, 20, 40 marks? Is that what you were thinking?
I don't even know.
Okay, well, let's figure it out. So there's 40 marks in total, and what did this person get? 8, and 16 would be 24, plus 6 would be 30.5. What is 30.5 out of 40? 0.76. Okay. Now, that is the average percent. So what about 0.76 times 76 times 0.15? What do you get there? Okay, so, sorry, that is what? 11.4. So these numbers are quite different, aren't they? They're quite different. So we can't do each one being worth 15%. So that one's off the board. We can't do this one. If it's 15% as a whole, I think what you can do is you can find the overall average. So you can average these percentages just equally, and you get 76%. Or you could add up all of the scores like I did over here, and then all of the score that he got or she got, and then find that average percent. Okay, so I think this one is going to be, let's keep it in blue over here so we know it's a different one. It's going to be, the average is 76 times the category weight of 0.15. Okay, so we settled that. That's a good question to get figured out. So they are different. The quizzes and the assignments, this wording is different. 15% altogether, you have to take the average of that category, multiply it by 15%. Each quiz is worth 5%. That's different. Okay. So let's do this now. Let's do all of this on our calculator, and we'll find out what our total percent is when we add this all up. Okay, so those are the percents now from each category. Whether you have your percent during the question, like your units during the question, doesn't matter to me as long as you have units at the end. So we add up all these, and then what do we get? So let's figure that out. That should be about. All right, so you add all those up, and it's 83.35. If you want to round that to the nearest percent, you could say 83%. But here's your exact answer. Okay. All right, so that's a good example for us to do. And yeah, so for build your skills, I'll get you to keep going on with build your skills here. So please do 1 to 6. Okay, you can have the rest of this class to finish 1 to 6, and we'll start on this part 2 tomorrow. Okay, so build your skills 1 to 6. Go ahead and work on that.